happy to have everybody here today, and we're actually very happy to have a special guest speaker today, Stan Mull from DEM International, and he's not quite so early in the morning or late at night, kind of right in the middle. Stan's joining us from Alaska, where it just turned over to midnight on December 2nd. So yeah, basically welcome to the webinar. We're just a few more people are filling into the room, so I'll sort of talk a little bit about what we're going to see here today. Before I get to that, though, I just want to make sure that everybody knows how the GoToWebinar system works. You're going to have a little panel on your screen that you can see there. I want you to know that right now your lines are muted during the course of this presentation. So if you're in a room full of people or you want to work on the side or answer some emails while you're listening to this, nothing's going to interrupt the proceedings, so don't worry about that. If you have a question, there is a dedicated questions panel there. I know I have a couple of questions that have come in so far. We will be saving those for the end at the question and answer session, depending on how much time we have there. Alternatively, you can raise your hand. There's a little button you can see in your interface there that's a little picture of a hand. You can click on that if you want to speak a question directly and are so equipped with a microphone to be able to do that. And lastly, one of the most popular questions we always get is, can I get a recording of this webinar? And yes, you can. We're recording this right now. It usually takes a day or so for us to compile that recording and put it into something usable that people can watch on their computers. But we will be sending out that recording after the session. Presenting today, like I mentioned, we have a special guest, Stan Mull from DEM. And Stan is the International Business Development Manager and Reseller Channel Manager at DEM Systems International in Anchorage, Alaska. Stan's got a master's degree in economic geology and remote sensing from Colorado State University in the United States, and a bachelor's degree in geography from the University of California, Santa Barbara. Stan has served as a chair and board member for the annual Alaska Surveying and Mapping Conference, and as the president of the Alaska chapter of EURISA. Freddie Paya, some of you may have met Freddie. Freddie's been doing a lot of traveling lately, so he has been around the world doing in-person conferences and events. But for those of you unaware, Freddie is an application specialist at PCI Geomatics, and he did just join the company earlier this year in 2014. But like I mentioned, he's already been very busy helping customers across the globe make the most of their Geomatica and their GXL installations. Freddie has a degree in geomatics from the University of Waterloo in Canada and a master's in engineering from Ryerson University, also here in Canada, in Toronto. Prior to joining PCI, Freddie had positions with Agriculture Canada, Natural Resources Canada, and more. So that's these are our presenters, and I'll talk a little bit briefly about what we're going to be talking about. So what we're going to be looking at today is elevation models, terrain models, and surface models, and all that. And these digital elevation models, they play a really important role in terrain-related GIS applications. And one of the many factors that affect the accuracy of your elevation models, your surface models, is the accuracy and the type of the source data. So if you're familiar with Geomatica and any of our other software, you know that we deal almost exclusively in optical imagery. And photogrammetric DEMs that are derived from stereo imagery are really good at collecting accurate terrain data, but there can be some issues in urban areas with buildings, and they can be difficult to create. So one of the solutions that people really like to use to build these things is by using Lidar data. And Lidar data is really great for getting elevation information, the heights of buildings, treetops, almost anything there. And we have Stan to talk a little bit more about what you can do with that. But what we're going to be doing here is there's a couple of ways to do this, and the workflow I have up here on the screen now is actually not what we're going to be doing here, but we're going to be showing you ways that you can basically combine your LiDAR data with optical data using software from DEM and software from PCI. This example here is a workflow that has some real-world applications where perhaps you've got some satellite or some modern aerial imagery, and you've got some historical air photos, all some scanned film slides and all that, and you can use that using our software You can bring those into Geomatica to create a point cloud using Geomatica's auto DEM module, and combine that with a Lidar point cloud. Bring that point cloud into landscape, which is the software we're going to be seeing demonstrated from DEM, and then using Summit Evolution to extract the 3D vector information and end up using this DEM to create beautiful orthophotos like we're known for doing here in Geomatica. This is a little bit too complex of a workflow, but I show it here as an example of what we can be doing with LiDAR data and optical data together. What we're going to be seeing today is actually a little bit of a simpler workflow that just popped up on your screen there. Is what do you do if you actually have raw LiDAR data and you want to use that to create your DEM to create your mosaic. So what we're going to have today is we're going to have some LiDAR data that's going to be ingested and edited in landscape, the DTM software, and then out of landscape we're going to generate a bare earth file in an LAS format, and then in the PCI software we're going to take that LAS file and compare it with a stereo imagery derived DEM and use the best areas of both, because your optical data and your LiDAR data are each going to have certain areas of occlusion or certain areas that may not quite be right, especially if you've got different dates. If you've got LiDAR data and optical data that were captured a number of years apart, there may be some differences with new structures and things that have been built in the time being, or changes in the geography. So with this cross-check here, what we're going to be doing is going to be looking at the DEMs that we've created from the LiDAR data and from the stereo DEM data and pick the best, most accurate one to create a high-quality orthomosaic in the end. So that's just about enough for me. Before I pass it on to Stan to talk about landscape software, I do want to ask a quick poll. We do have a number of these. We just want to basically know what you guys what everybody out there is doing and using in their daily work. So basically the first poll question I have here is how familiar are you, if at all, with using LiDAR data, and if so, is landscape your software of choice, or do we have any other options out there? You see there are a number of software options there. Excellent. Thanks, everybody. Got a number of great responses there, and interestingly, a large number of people there not really using LiDAR data at all, not familiar with it. So this is a really great opportunity for everybody online to learn what you can do with LiDAR and what makes it useful, and how you can work with it using landscape software. So with that is it for me for now. I will be back with a couple of more polls, and I will be hosting the question and answer session. But at this point, I'll just pass it on to Stan, and Stan's going to talk a little bit about LiDAR and landscape software. Stan, the mic is open. It's all yours.
All right. Well, thank you, Jason. It's my pleasure today to introduce you to Landscape, DATEM's essential point cloud editing tool. Most of the time, point clouds will be from LiDAR, but bear in mind that a point cloud really is only a with X, Y, and Z values.
Stan, I would like to interrupt for just one moment. I'm not sure if your microphone is off or really, really low, but you are very, very quiet right now. So I wonder.
Let's try this again. Is that better?
That sounds excellent. Thank you.
All right. Well, thanks again, Jason. It's my pleasure today to introduce you to Landscape, DATEM's essential point cloud editing tool. Most of the time, point clouds will be from LiDAR, but bear in mind that a point cloud really is only a collection of points with X, Y, and Z values, probably but not necessarily randomly spaced, and with 0 or more attributes associated with each point. Thus, a point cloud can also be generated using an auto DEM process from stereo imagery, or a regular DEM grid from acoustic bathymetric data, mobile or ground LiDAR, or pretty much anything else capable of making a collection of X, Y, Z points. So I'm going to run through a series of slides that will show you the landscape interface and then show you the landscape interface. So now on my desk I have a couple of specialty items that I'm using to drive this software. First of all is this 3D data input device, which is a 3D, also known as a 3D cursor. I'm currently using this one here on my desk, and it lets me control X and Y as well as the height of my floating point or the cursor on the screen. It also has controls to allow me to digitize in 3D and programmable buttons to issue commands. It therefore frees my system mouse for other tasks. Also on my desk is a stereo-capable monitor which allows me to view imagery and objects in 3D stereo. It's very important for working with 3D data, although not always strictly necessary depending on the task at hand. We're going to try and take a look at some 3D data here. We'll use an anaglyph mode to do that since 3D stereo across the internet is kind of cumbersome. So there are a lot of ways to configure the landscape software to suit your viewing and operating preferences. I'll not dwell on these in particular because you'll have these slides afterwards anyway for your review. We'll take a look at some of these live anyway. Basically, you can view your point cloud from any direction, angle, or zoom level, including a profile window, which we might look at if we have time. It's also possible to render your view in several other different ways. The points method is the most common. So here are some ways of viewing that. The points, as I say, is the most common. Now, DATEM, one of the signature capabilities of landscape, and with Summit Evolution for that matter, is the ability to digitize and work with vectors. There are two principal reasons you'd want to do this. First, to identify areas you want to edit for some reason, such as reclassifying lake points to a single class, or secondly, to identify and extract features for later use, such as defining the tops of buildings to control a true ortho. Landscape has its own built-in mini-CAD, we call it, and we call this cleverly the DATEM drawing tools. It supports all the major vector formats supported by our DATEM capture tool, including AutoCAD, MicroStation, and Esri formats. Its primary purpose of the DDT is to provide simple tools for point editing. Now, I got my slides a little bit out of order. We also yes, I did get them out of order. So for simple editing, one can select a single point or multiple points using the DATEM drawing tools or our point edit tools. Simple manual manipulation of the points can be done in this way. Here we see a simple rectangle being used to delete points. For more complex and sophisticated feature collection, we suggest using DATEM capture with a full companion vector editor, such as ArcGIS or Bentley MicroStation or AutoCAD, or Summit Evolution. This provides all the tools one might need for very sophisticated editing, classifying, and feature extraction from point clouds when coupled with a stereo model. So lastly, we see how points can be reclassified or deleted using the classification filters. We'll take a little closer look at this in a moment, but depending on the density and quality of your data, you can employ these filters to find very fine features, such as power line catenaries, or gross features such as roads. But each area is different, so it can take some experimentation and or prior knowledge to design the correct filter parameters. So here again is an example of some of the catenaries and other features that one might see in a point cloud. So let's take a look at landscape, shall we? Now on our right here is landscape, and on the left is summit evolution, which is our stereo plotter. The two are showing the same area, and or should be anyway. Bear with me just a moment. All right. So now we're basically seeing the same area, and on the as you can see, well, let me see just a moment. All right. The two are showing the same area, and movement is synchronized. In the landscape window, we see the original LiDAR data set provided by Freddie, and in the left we have the stereo pair, which Freddie will process into an orthophoto. We control the points that are loaded into landscape and hence effectively manage memory in those projects that may have hundreds of millions of points, especially in machines with less capacity such as this one. We loaded only those points in the display window so we can increase the visual density. Turning this off loads a sparser set of data. Note too that these points can be viewed in a stereo window if desired. So I'm going to show again these points here. I'm going to set this so that we're looking at just those points in a window. I'm going to reload them again, and you'll see a little bit of processing going on down at the bottom, and we'll try and move in. And that's, sorry, I should have this a little bit better synchronized. All right, now I've got something going. All right, so those guys are more or less synchronized. So you'll notice down at the bottom here that we have, it says 33% of points in the area. This is so that we can control the memory management within the system. And when we're trying to show these things over the top of the Summit Evolution product, we can also do that in a more manageable way. So so it's difficult to show stereo over the internet, as I said. So I'm going to show this from change this so you can actually see that this is in stereo. Turn on anaglyph mode, and now you can see quite readily that these points are in fact, these images are in fact lining up. And with the cursor on the right in landscape and the cursor on the left, you can see that they are mostly lining up. And the reason that they're not lining up is because we're looking at an orthogonal view from in the landscape window, and we're looking at a stereo pair with perspective in the summit window. So anyway, I'm going to get rid of the Summit Evolution window at this point and move on to work with landscape just a little bit. So now on the right is the project overview window, as we can see over here. It's always colored by the Z value. To add data to the landscape project is just as simple as dragging in any point or vector file, and landscape knows pretty much what to do with it. That means it need not necessarily be a LAS file. It could be a bin file or an XYZ file or an ASCII file for that matter. And if it can be rendered into a point file, then landscape pretty much knows how to take care of it. These files that I'm using today are actually LAS files, which happen to be also the native format for landscape point clouds. We can see several ways to view the data. We can view it with class, which is pretty boring right now because we don't have anything classified. As you can see on the right down here, we have 683,000 points loaded in, and they're all essentially unclassified at this point in time. We can render it based upon the Z value. We can or elevation. We can render it based upon the flight line, the return number. In this case, we can see we have 2 returns in this data set. If we had an orthophoto or RGB information stored within the file, we could render it in as if it were an image. It's a little bit of a challenge because you're not always looking straight down at the ground, but and then also you can look at it based on the file number if you have more than one file going at any given time. So there's also a way of looking at it using the intensity, but unfortunately, if you're using something other than LAS, you may not have intensity. Other than LiDAR, you may not have intensity information, such as with an auto DEM process. So to show how we might begin processing this data set, one might start with creating a selection set. So let me bring this up here with our LiDAR filter. Our LiDAR filter editor, which basically has a number of different filters which are defined, and they're built using the different attributes in the file that are associated with that point. With LiDAR data, it's primarily these ones that are exhibited here: return number, timestamp, class, etc. And so these are the attributes that can be used to develop a filter. Also, you can use geographic objects like any vector information that you might have digitized or imported from another project to define an exclusion area. So these then select the points you'll operate on. Now the heavy lifting then comes with the filter points dialog. Each of these is designed to extricate different types of data from the data set. I started mine with the unclassified data and ran the bare earth filter, this one here, which uses a selection set, as we just talked about, as a starting set, another set as a seed if you have that, or basically just tell it to find the low points, and then establish a few parameters, and the straightforward result is shown here. So now what we have in brown is the ground, that's the bare earth, and then everything else is unclassified. Out of the 771,000 points, about a third of them classified as ground. Now, just to show you how this looks, we can look at it in profile. And I will draw a profile line and through pretty much any place we want to, and turn off the unclassified data, and you can see this stuff is pretty flat. You can do this wherever we roam around in this data set. Establish another profile line, and again you can see that it's pretty flat. So that was a pretty good start. To carry on with this a little bit further might involve doing a little bit more refined editing on this, but I'm pretty happy with this for the time being. So the next step then would be to try and do another classification on this. So we'll do the building filters. Similarly, it starts with the initial selection set, and now a ground class so that it knows where to stop the building at, and a set of parameters that describe the shape and configuration of most of the buildings that you're trying to look at. So, or look for. As you can see now, rather than run this, because this takes a fair amount of time to run this, I'm going to just show you the results. So the results of this, basically, as you can see, it got most of the building roofs in the first pass, and iterative operations with modified parameters will improve the results. I'm going to look at this again, only in a slightly different way. We're going to rotate this and then spin around, and you can see now that it got the roofs of these buildings pretty well. Everything else besides the ground and the rooftops of the buildings is still unclassified, and you can see where this is. If I turn off the intensity, you can see that these points are still there and still ready to be operated on. So since these projects can get quite large and the processing can take time, there's a batch facility so you can get some sleep while the processors think. And then of course the output is to a normal LAS file, which Freddie can ingest and is going to use for his next process. Back to you, Kevin. Or Jason, I mean, it's back to you too.
Oh, sorry, I had accidentally muted myself there. What we're looking at here is Freddie's going to take the lidar data that was processed using the DTM software and bring it into Geomatica to produce a DEM and an Orthophoto. So as I can see, I didn't have to explain the poll. Many of you have voted already. So a small number of you aren't really working with optical imagery right now, but most of you seem to be, and a pretty even split with what people are using. A lot of you using Geomatica, which is great. And for those of you that are not using Geomatica, Freddie's going to show you why you should be using Geomatica. So that's it for me for now. We're going to have Freddie's going to give the demonstration. Then I'm going to be back with one more poll before the question and answer session, and we'll wrap it up shortly after then. But anyway, now it's Freddie. It's on to you to show us what we're going to do with this last file.
Okay, thank you, Jason. So we've seen the first step of this workflow. We've seen how using landscape we can classify the points. Now we can use the Geomatica Lidar Tools to convert from a LAS file into a DSM. So let's show you. Let me show you the first step here. How we can use these tools to create a raster DSM that we can use to create at the end the orthophotos. So the process in Geomatica is very simple, it's very straightforward, and it involves only 3 steps.
I just want to cut in a second there, Freddie. I'm not seeing your screen. It might just be me, but perhaps you haven't shared the screen yet.
Let me try. Okay. Do you see my screen now, Jason?
I see it now. That's perfect.
Okay, perfect. So I'm just going to go back and show you the workflow. So as I said before, we've seen the first step, which is a classification of the point cloud using landscape. So now I'm going to show you the second step, which is using the Geomatica Lidar Tools to create the raster DSM. So as I was saying before, the generation process is very simple, and it includes 3 steps. We can create these using Easy, which is a programming language in Geomatica, or we can also use Python, which obviously gives more flexibility for people who do not know how to use Easy or Easy before. So just to talk in more detail about the first 3 steps. So the first one is ingest, which pretty much ingests multiple vector files and merges all these files into a vector. So you can import not only point clouds, but you can import break lines, you can import contours. The points not necessarily have to be in a LAS format. They can be in a text file, for example, or a shape file as well, so we give that flexibility. The second step is the setup, which creates an index file that contains a list of rasters that will be created by the last step, which is interpolate. So interpolate, as the name says, it interpolates all the raster DEMs and all the elevation values and all the vector points to create finally a raster DSM or DEM. So here we have all the different data sets that we can include in this process. For this example that Stan was showing you, which is downtown Toronto, we have about 3.2 million points. For this example, we're going to be only using the point cloud. So let me go to focus and show you how can we import the Python scripts. So when we open focus, we're going to go to tools and we're going to go to Python scripting. When we go to Python scripting, we can just quickly open our file here. So we can go to where we have our folders, where we have our script, and we can just import our script. So as you can see here, I'm calling the 3 tools that are used to convert from a point cloud to a DSM, and these are all the attributes that are needed for each tool. So basically just calling the path where we have our point cloud, what kind of return we need. It can be the last return, it can be all the returns, or it can be the first one, and all these different attributes that we need to save our output file and everything else. So when we're satisfied with our scripting, we can just click run, and what we're going to get is basically our DSM. So let me just zoom in here. So when we have our DSM, we can do a quality control. So basically, we can use this tool called DEM, the live DEM tool. So as you can see, as soon as you open this tool, it's going to change the colors to a pseudo color, so we can see the high elevation values and the low elevation values. One interesting tool that we can use here is the fly tool, which basically it allows me to fly through the terrain. So I'm going to just do a quality control, just to fly a little bit over my area in downtown Toronto. We can see all the buildings, we can see all these different features that is important to inspect before we want to go ahead and with our workflow. So I can just quickly fly through and, as I said, inspect all these features. So when we're satisfied with that, we can continue with our process. So I'm just going to close this now. So we've done the second step, which is using our tools in Geomatica to convert from a LAS file to a DSM. So now that we have the DSM, we're going to use a live DEM tool to convert that into a DTM. So there's two options to convert that into a DTM in Geomatica. We can use one of our algorithms, which is DSM to DTM, which pretty much, as the name says, it converts from DSM to a DTM. Or we can use a live DEM tool, which is the one that I was showing you a few seconds ago, to convert that DSM into a DTM. So basically what I usually do when I'm in Focus, I open up my algorithm librarian and I use my DSM to DTM tool, and I just run my DSM, and when I get my output file, I use the live DEM tool, which can be found under layer, and it's this one here. So this is more of a manual tool. So basically I'm going to create a temporary file, and I'm going to draw a polygon around my area. So I'll just quickly draw a polygon here. And there's a variety of operations. We can use the terrain filter flat because the downtown Toronto is a flat area in elevation, and we can apply this filter in order to remove all these large objects. So I'm going to apply, and as you can see, most of the large objects are removed. We can change the size to perhaps 10 and the gradient to 5. We can apply again this operation. As you can see, most of the large objects are removed. I can go ahead and play around even further with some of the operations. I can remove bumps, or I can remove pits, and so on. So basically, at the end, we're gonna get a file that looks like this. So this is our final DTM. And now we can go ahead and continue with the process with OrthoEngine. So when we're done with the DTM conversion, we can go to OrthoEngine and set up our project so we can finally create our Orthophotos using our DTM that it was converted from our point cloud. So I don't know if some of you have used OrthoEngine before, but it's one of our tools in Geomatica, and it's a powerful tool designed to handle production workflows to efficiently create geospatial products. So in the OrthoEngine requirements for this project specifically, we need the camera calibration file, we need the exterior orientation file, we have all the we need the stereo images that we have from AutoCAM 15 centimeter resolution, obviously for the same area in downtown Toronto, and we need the DTM, which we have already created. So with all this information, we can go ahead and create the Orthophotos. So I'm gonna go to my OrthoEngine here. So as you can see, it's very simple to use. We have a processing step which goes down the list. So when we go to project, we just set up our projection, for example, here. We set up our resolution. We can set up our camera calibration on the first step as well. We have the focal length, we have the chip size, and all this information that is needed to create accurate orthophotos or mosaics. We go down the list to data input. We can import our images here. So as you can see, I've included 9 images for this project. We import our exterior orientation file. So here we can just go browse, and then we find our exterior orientation file and import that as well. And when we're done with that, we can move down the list to the ortho generation. So here in the ortho generation, we can see all the images that are available for this project. So what I'm going to do is going to highlight all these images, and I'm going to click here to process these images. So when we have that there, we can just select our name for the final images. We can go here to ortho generation options, and we're going to select our final DTM that we've created over this workflow. So I'm going to go here to select my final DTM, which is this one here. We can look at the info for the DM, make sure everything is okay, and we go okay. And basically, we just click Generate Orthos. It's going to take a few minutes, but the result looks like this. Let me just go back to my PowerPoint. These are the orthos obviously they're overlaying one each other. These are just their this is not the mosaic, the final mosaic, so that's why you can see some overlap in these area. We can do some quality control as well using Google Earth. So as you can see, I've overlaid the final orthos in Google Earth, and this is what it looks like. Let me show you on Google Earth how it actually looks like. So I want to turn this one off, and I'm going to zoom in a little bit here, so you see the streets are well aligned. Everything looks fine. I'm going to turn this off, turn this back on. So as you can see, we've created an accurate ortho. So when we're satisfied with this, we can go ahead and create the final mosaic. So that's one workflow that we can use to create ortho mosaics using a point cloud or other vectors that we have. We are showing you another workflow here. In this workflow, we won't be using any vector data, but we're going to be creating the DSM and after that a DTM from the stereo images. So the first step to run this workflow is to create a DSM using OrthoEngine with all the required files that I explained to you previously. So we have the camera calibration file, we have the exterior orientation file, we have all the stereo images. So the first thing we're going to do is to create epipolar images that will allow us to extract the DSM in OrthoEngine. So let me go back to my OrthoEngine project. So I've shown you the first three steps for the input of those required files. So we can go down to DEM from stereo. And the first step we're going to do is to click on this create epipolar image. So here in this window, you can see that there's a variety of options you can select. You can do optimal pairs, you can do overlapping pairs, you can do maximum overlapping pairs, or you can select your own pairs. So basically, you're going to click on one of these left images, and then the tool is going to find what overlapping images are with that specific image, so you can click create a pair. So I've created all my pairs here, but basically you can just click on these add epipolar pairs to the table, and then it's going to select, depending on what option you chose. So for mine is optimum pairs, it's going to select the optimum pairs for each specific image. When you have all the pairs here showing you all this information, you can just quickly click on generate pairs, and it's going to generate all the different epipolar images that are used to, as I said before, to create and extract the DSM. When we obtain the final results from the epipolar images, we can go to extract DEM, and here we can see all the epipolar images that have been created and saved in our folders. We can just select the ones that we want to use. We don't necessarily have to use them all, but we can just either select them all or select specific ones that we want to use. We can play around here with the options, for example, the terrain type, the TN detail, the channel type, all this information that is important to create an accurate DEM. So we're going to check this off, create geocoded DEM. We're going to select our output file, so I'm going to do test here. And I'm going to choose my resolution. So for this example, I used a 1 meter to 1 meter resolution. So when I'm satisfied with all my options, I can just go extract DEM. So I've selected all. You can go extract DEM here, and then I'm going to show you what the output looks like. So basically, this is the DSM generated from the stereo images. As you can tell, it's not as accurate as the one generated from the LiDAR points. So when we have the DSM that was generated with OrthoEngine, we can go ahead and use the live DEM tool or the DSM to DTM tool to create a DTM. So I've shown you that step before in the previous example. So these are the two options we can use in Geomatica to do the conversion from DSM to DTM. When we've generated our DTM using one of those tools, and when we're satisfied with our DTM, we can obviously use the quality control using the fly tool, as I showed you before. We can move on to our final step. So in our final step, we're going to go back to OrthoEngine. We have all this information. We have all these files. We now have the DTM that we've created through this workflow. And with all that information, we're going to create the orthophotos. Here's the three required files. So now we have the epipolar images, we have the DTM. So we're going to move down to our final step, which is the orthophotos. So I'm going to go back to OrthoEngine, and as I said before, we go to Ortho Generation. I already have all my images to process, but basically you're going to have them all here in available images, and you're going to select which ones you want to ortho rectify and which one you want to process. We're going to choose our new DEM, which is the one that we created in this workflow, and then we're going to go generate orthos once again. So when we get our final results, we get an ortho photos that looks like this. Once again, this is not the final mosaic, but these are just ortho photos overlaid on top of another. So we can do the quality control once again on Google Earth. So let me go back to Google Earth, and this is the example for this one of the ortho photos that I created. So you can see it's well aligned with the streets and the highways here in downtown Toronto. We can take a look at the buildings as well, that everything looks aligned and properly. So everything looks fine. So we can just move forward with our workflow. So how can we obtain the best DTM? How can we obtain the optimal DTM that we want to use? So we can do a comparison between the two DTMs. So we've created the DTM from the stereo imagery, and we've created the DTM from the lidar points. So perhaps one of them is more accurate than the other one. Perhaps one has more area than the other one, and we need a bigger DTM. So we need to find what areas are better from one to the other one. So we can do a combination. We can do a mixture of both in order to have the best DTM. So I'm going to show you quickly what we can do, what kind of workflows we can do in order to obtain the best DTM. So I quickly ran a change detection between the two DTMs. So this is a ratio between the two DTMs in order to find what areas show the most difference between one DTM to the other one. So as you can see here, we have these areas on the bottom of the DSM shown in red that obviously show the most difference between one another. So when we go ahead and take a look at these areas, we can see that there's some occlusion, there's some distortion between the two in the stereo images between the two DTMs. So you can see on the left image how that building is very distorted, is very occluded in the orthophoto created from the stereo image compared to the one created from the point cloud that is well aligned. There's no distortion. So this is important to investigate, because we don't want to be using a DTM that has these kind of problems. So I'm going to go to focus, and I have my two DTMs. So you can see the one process from the point cloud here, and you can see the one process from the stereo images. So as I said before, I've ran a change detection. So here I can see the areas that have significant difference between the two, and I've created a few polygons around these areas because I want to copy and paste from one DTM to the other to, as I said before, have the optimal DTM. So what I'm going to do now, before I go ahead, I can show you quickly the areas of distortion here. So let me just zoom in this area right here. So you can see here how the highways are distorted, and the buildings as well in this stereo image, and this ortho generated from the stereo images. Let me just show you. You can see the cars and the highways here, whereas in the lidar orthos, you can see we don't have this problem. So that is shown in the change detection analysis that I ran between the two DTMs. So what I'm going to do now is I'm going to select an area and I'm going to copy and paste using the Smart GeoFill. So when I go to Tools, I can find my Smart GeoFill. So Smart GeoFill is it's a very interactive tool that we can use to copy and paste from one image or DSM or DEM or whatever to another. It copies in all the channels, not only one, which is fundamental when you want to copy one area to another image in all the channels. So I'm going to select my source, which is going to be my DTM from Lidar, and my destination, which is my DTM from stereo. That's going to be my destination where I'm going to be copying this specific area that I'm going to select here. So when I have my source image and my destination image, I can play around with the options here. So I'm going to select an overlap color balance method. We can always go back and change other methods or play around with the contrast and the brightness. But for this specific example, I'm going to select overlap. So I'm going to close this up, and when I have my area selected, I can just go copy and I can go paste. So it takes a few seconds, and as you can see, and now I have copy and paste this area here from one DTM to the other. So that's basically an important way of fixing up DTMs or images and creating the optimal DTM in this case, for example. So that's one of the workflows we can follow in order to create very accurate orthos. If we wanted to continue, we can also, for example, going back here in my focus window, we can looking at the change detection, we can run with the raster calculator an analysis to find all these areas that are very different, that are usually distorted or occluded. And then when we have a raster showing all these areas, we can use the export ras tool, which is a tool in Geomatica to vectorize rasters. And then when we have a vector file with all these areas, we can just quickly go run this Smart GeoFill. So it's a more dynamic way of extracting all these areas, so we can copy and paste from one DTM to the other. So that's another workflow we can follow in order to make it faster and more dynamic. So that's basically how we can run Geomatica and Landscape to create accurate orthophotos. So now I'm going to pass it back to you, Jason.
Excellent. Thanks, Freddie. I'll take back control here, and I will show my screen for the question and answer session. But before we get to that, one last poll. We want to make sure everybody was following along. This is not a test, but just want to know what did you think about what we showed here today? So either, I think Freddie really pulled it all together at the end, showing that that your optically derived product can have some weird distortions in areas of occlusion, and the lidar data also has some certain limitations that provide the same thing. And by being able to using our Smart GeoFill technology, that you can come up with an accurate end product really quickly and easily. And wow, this is fantastic news so far. With the majority of people voting, we've got over 90% are saying that this workflow looks like something that can be of use. So there are a couple of questions that come in. If you have a question, now is the time. Enter it in the questions box, and we will ask our presenters. But the first question that we've got along, these are great questions to have, is basically how do I get my hands on this software? And a couple of you have asked that question, although not in so many words. So I'll speak to the PCI portion first, and then I'll get Stan to fill in some blanks on DATEM. the easiest way to get your hands on the software is you can visit our website at PCIGeomatics.com. Geomatica has a free trial. It's a 15-day trial license that is available at getgeomatica.com. That'll take you directly to our download page, and that will allow you to get a fully functioning trial of Geomatica. DATEM also has demo versions of their software at datem.com/demo. But I did want to just ask Stan, and I'll unmute him shortly. We had a couple of questions about whether or not landscape is a standalone module or what that. And basically, I guess what the question is with PCI and on the Geomatica side, we have a number of what we call modules that work right into Geomatica. But I want to explain that what Stan was showing with DATEM is its own standalone software package that is sold and supported by DATEM. PCI does resell this software in certain territories that I'm not 100% sure on, but I'm just going to I'll open up Stan's mic, and maybe Stan can clear up if somebody is looking to buy Landscape or Summit Evolution. How do they go about doing that, Stan?
Well, that's the kind of question I like to answer. They are. It's very possible to get the DATEM software through us or through PCI. The two are independent pieces of software. Summit works by itself. Landscape works by itself. They also work together, so they're not really modules of one another. They're independent but interdependent pieces of software. So you can use capture, you can use landscape with itself. You can add a module of capture, or if you think you're going to be using Lidar and stereo imagery of any type, then you may want to try and marry that with the photogrammetric capabilities of Summit Evolution. So in order to get the software, you can certainly apply to receive an evaluation copy. There's two simple ways to do it. Both of them basically wind up coming through me. In the long run, you can apply through datem.com/demo and fill out the form there, and that will be submitted and come through me. Or it will. You can write to me at sales@datem.com and ask for a demo as well. And those are easy to do. It's all done with software locks, so it can all be done with over email. And so it's helpful. As I explained at the beginning of my presentation, if you have the 3D software, the 3D hardware, the specialty hardware, it's possible to use it without those, but the experience is diminished. So we strongly recommend it. But for testing it out, you can get away with a system mouse and a 2D monitor. So either of those two ways, you can apply for it. Same with Summit Evolution.
Perfect. Thanks, Stan. And we're right up against the top of the hour here, but there's a question here that I think Freddie would be able to handle, and if I know it correctly, the question is about how is the software handle DSMs of different resolution? And I assume the questioner is talking about smart GeoFill. If you're trying to copy and paste a DSM of a different resolution into another, is that fairly seamless, or are there any obstacles to doing that there, Freddie?
No, it's a very seamless tool, so it's going to take care of the georeferencing. So even if you have two images or DSMs in a different projection, the tool is going to take care of that as well, and also with the resolution. So you can have a 1 meter resolution DEM and another one with a 15 centimeters. It's okay. It's not going to be a problem to copy and paste between different DSMs or images in Smart GeoFill.
Perfect. That's excellent, and not too many questions today, but I think we got a couple of good ones. If there are any further questions from anybody out there, if I know as soon as I usually get off the phone with somebody, I think, I should have asked that question. So as soon as I end this webinar, which will be shortly, if you think of these questions, feel free to ask them to either Stan at sales@datem.com or us at PCI Geomatics at info@PCIGeomatics.com. I want to thank everybody for joining us today, for staying up late or getting up early, whatever everybody had to do to join us. I want to thank Stan and the team at DTM for putting together their demonstration and staying up late where they are in the far west coast of the United States. Freddie for putting together our demonstration, and we hope to talk to everybody again soon. Keep your eye on PCIGeomatics.com/webinars for when our next webinar is going to be. We try to do these every month. I know we're going to have a Christmas break coming up at the end of this month, so it might be into the new year when we have a new webinar, but keep posted, and we will let you know. Thanks again, everybody, and we hope to talk to you soon.